Looks like I hit stop recording instead of pause on that one, so we're just starting a new video. Here is the answer. What it says correct. The secant function is not defined when cosine function is equal to 0. So this we just got to find out when does this function equal 0, and that's at pi over 2 or 3 pi over 2. So we need to figure out when. If you take inverse cosine of 0, that's going to be pi over 2 and 3 pi over 2. There we go. So this is going to start video 5, I think we're on. So number 23, video 5. The function g is given by g of x equals 3 cosine of this, which the following describes the range of g. So the range for cosine and secant is going to be all the things. As we flip it, it's going to be all the, so how can I say this? It's going to be the inverse of whatever your reciprocal function is. So for example, cosecant is sine. Cosecant is sine, right? That's the reciprocal function. And sine has a range of -1 to +1. And so we want the opposite of that. But then there's a bunch of extra stuff in here. And range is a vertical measurement. Range is a vertical measurement. So I actually don't care about the horizontal part here or the horizontal part here. What I do care about is that this is a 3. So this should make the range for this is the max to the min. This is the minimum, this is the max. So the min to the max. The max, if you remember our rules, the max is the amplitude plus the midline, plus the midline, or plus the vertical shift. So in this case, the max is going to be 3 plus a -1. So our max should be 2. And the minimum is amplitude. Technically, it's amplitude, midline minus, switch those around just to make it consistent, but it's mid minus the amplitude. Amplitude, can't spell. And the midline is -1 minus 3, so this should be a -4. So sine would have, in this case, sine would have a range from, sine theta has a range from -4 to +2. This would be the range, this should be included. This would be the range of sine. Now, when you flip it, when you take the reciprocal of sine, it takes everything on the outside of this. So your domain should be everything that's from -infinity to 4. So it should be from -infinity to -4, inclusive on the 4, union to +infinity. So we want the outsides of those. So let's see what our options are here. The range is -infinity, great. -infinity to -4, union 2 to infinity. And that is just to look at another, where'd one of these, what's happening is that the sine wave, so for this is cosine, but the cosine wave, these little points are the spots. So that is where your cosine wave would be, and it flips, the reciprocal flips it, pops it up to the inside, turns it inside out. Okay, 24. The function f is defined by f of x equals 3 secant. The function g is defined by 1 over that. Which of the following of the graph of g? So we want to figure out what g is. So if I know that f of x is 3 secant. I need to figure out what this is. So I plug this in. So g of x is equal to 1 over f of x. And f of x is 3 secant x. So 1 over secant is 1 over secant is cosine. So this should be cosine of x over 3, or you can rewrite it as 1/3 cosine x is what we're trying to graph here. The amplitude is 1/3. The period is 2 pi, because we didn't change our periods to be the same. Period is 2 pi. There's no vertical shift and there's no phase shift. So because this is cosine, it has to start at a max. So that starts at a max. This one is sine, starts in the midline. This is cosine, great. Oh, and that's sine. That starts at a midline. So it's got to be A or C. And because our amplitude is 1/3, not 3, it should be A, which is that amplitude is smaller than 1. Okay, 25. Looks like we're out of the reciprocal function graphing. Hooray. The figure gives the right triangle, where y is the length of the side opposite of A. Yep, so y is opposite of A. And if the function f gives the values of A as a function of y, so it gives A as a function of y, so A of y, which of the following could define f of y, or I guess A of y, sure, why not? So since this is opposite over hypotenuse, right? So so opposite is sine. So if you look at SOHCAHTOA, so ka toa. Oops. I know opposite and hypotenuse, so it's got to be sine. So sine of A should equal y over 12. So look down here, sine, so it's not C that uses cosine, it's not A that uses cosine. Now sine of A equals y over 12. This is the ratio. And if I want to get A by itself, or A of y by itself, or f of y, whatever you want to call it, I need to get rid of sine, so I need to take inverse sine on both sides. So A or f of y, whatever, is equal to inverse sine of y over 12. So it should be D. Do not put ratios. Do not put ratios into trig functions. These must be angles. These must be angles. So do not put ratios inside the trig functions. Ratios go inside inverse trig functions. 26. The function f is given by f of x equals 3 cosine. Which of the following is the inverse? So we want to find inverse. So we have to first start by swapping x and y. So if we're looking at this, it's going to be 3 cosine pi x. Swap x and y. So x is equal to 3 cosine pi times y. And now we just got to get y by itself. So start by dividing by 3. X over 3 is equal to cosine of pi y. We then take the inverse cosine of both sides. So we'll have inverse cosine of x over 3. And whenever you take inverse cosine, you have to do plus 2 pi. Okay? Oh, here they just restrict the domain. So the domain is restricted to quadrants 1 and 2. So it's going to be, we'll get to that here in a second. Actually, look, all the restricted domains are the same. So we don't even have to worry about the restricted domains. It's all our answers the same. So this is going to be equal to pi y. And then we divide both sides by pi, or multiply by the reciprocal, and we get 1 over pi inverse cosine of x over 3 is equal to y. So this would be equal to f inverse of x with the restricted domain after you divide by pi. So we end up getting 1 over pi, and this should be d. 1 over pi inverse cosine of x over 3. 27. Which figure of the graph gives the function f and g? Wait, the figures. The figure gives the graphs of the functions f and g. This is graph of g, this is graph of f. Okay. The function f is given by the inverse tangent of x. So this is the inverse tangent of x. That's great. It has flipped over. Great. Which of the following defines g? So, what has shifted here? It looks like, what are my options? So inverse tangent of x, this is a vertical shift. This is a vertical shift. All of these, this one is I'm off the screen. This is a vertical shift because the only thing that's changed, because this is tan x, inverse tan of x, the only thing that's changed here is this +1, and it's on the outside of the trig function. So that's a vertical shift only. This is a vertical shift only. This one here is a vertical shift, and this one here is a vertical shift, and it is a period change. It's a period, so stretch. This is a stretch. Because we are inside the parentheses, so it goes, dividing would be a stretch. And this one is a vertical shift and a period stretch. Okay, so let's see what's actually happening up here. So since we're not moving left or right, this is a good spot to start with. 0 is awesome. Lots of things cancel out. And it looks like from 0, we have moved up 1. So this is a vertical shift of 1. So a vertical shift of 1 crosses out B and crosses out D. Now we know if there's any kind of stretch or compress. So let's pick a point that looks relatively easy. So this right here, this point right here, oops, I'm off the screen. This point right here is 2, and it's about 1.1-ish. And maybe not even, 1.05 or something like that. I don't know, it's pretty close to 1. Pretty close to 1. If I compare down here, 2 to this spot right here, this point is 2, 1, and it's pretty close to 2, so it's pretty close to 1.9. So that means there absolutely was a stretch. Oh, no, sorry, I increased by, this is an increase of not 1. If this went up 1 exactly, 2, by vertically shifting, this should have gone up to, this point should have transferred to 2.05 or 2.1. But if we look at it, it is actually below 2, not above it. This would be above the 2 mark, because we had to give a vertical stretch of 1. So there was a stretch involved, which means it has to be C. It has to be C because there's definitely a stretch involved, because this changed differently than just a vertical shift. Okay. What number are we on? 28. We can squeeze one more on this video. Let's see. The graph of the sinusoidal function f in the xy plane. What is the length of the largest interval of input values of f on which the inverse function of f can be constructed? Okay, that is a very, very complicated way of saying, how do I make this a one-to-one function? So how do I make this graph pass the vertical line test? So the vertical line test and the horizontal line test. So if I draw a graph, if I draw a horizontal line right here, it would fail at this point and this point. So I need to cross out the edges here until I would get to a spot where it uh, um, wouldn't fail the horizontal line test. So I'm going to cross it out right here. So if I ignore that part right there, now this part above the x-axis will pass the horizontal line test. Like we're ignoring that, so that'll be fine. If I look over here though, this part over here fails the horizontal line test. So we are going to cut off this side as well until it will pass the horizontal line test. So this little section here, from 1 all the way to 3, I would have to restrict the domain that small to invert this, to make this have an inverse. So the largest range is 3 minus 1, which is 2. B. B. Okay, I'll see you guys in video 7 or 6. 6 or 7. See.